For this problem, we've been given the original function y equals f of x, and we want to apply this transformation. So what we would need to break down is the outside transformation versus the inside transformation, or the change in y and the change in x. So when we look at the f of x, so I've made this a little bit easier because I've color-coded this, but I want to see clearly, I want to be able to identify clearly what's on the outside of the f, which affects vertical, and what's on the inside. So when I look at the transformation equation, so I have, firstly, it's going to be 2 times f of x. So my first thing is going to be, my new y is going to be, I'm just going to rewrite it the way it is, 2 times old y plus 2, and then negative on the outside. So the first step is I'm going to vertically expand by 2. I'm going to vertically shift up 2. And then lastly, I'm going to vertically flip it. So I make negatives positive and positives negative. So when I take a look at my transformation of my coordinates, just looking at the y's, I'm going to take that equation and transform the y coordinates. So I'm going to go 2 times y plus 2 and then flip it. So 2 times 7 plus 2 is 16. I end up with flipped negative 16. 3 times 2 plus 2 is 8. I flip it. I get negative 8. 6 times 2 plus 2 is 14. I flip it. And I get negative 14. So there's my y transformations. So those are the easier ones. The harder one's going to be with the change in x. So the change in x is going to be based on the inside part here. So there's 2 ways we can do this. And I'll do it both ways, but one way is we can think of this as factored form. So I can check to see if it's factored form. If it's factored form, then it's going to be compression expansion first, shift last. So the way it's written, that 1/3 coefficient is in factored form. Although it's in the denominator, it's still part of both terms, x and negative 3, so it's in factored form. So one way I can do this is I can say, well, because it's factored form, I know it's going to be a horizontal expansion by 3, and then it's going to be shift last. So horizontal shift plus 3. So that's one way we can do it. We could also use our function notation and say that, well, the notation is backwards of what I really want. Okay, so if I want to calculate my new x, I have to undo this notation, and I get times by 3 first, and then do plus 3 on both sides. So then that equation will do my transformation. And again, if you notice, the equation is going to be the expansion first, shift last. So I'm going to apply that equation to these terms and then do my transformation. So it's going to be 3x plus 3. So 3 times negative 2 is negative 6, plus 3 is negative 3. 3 times 1 is 3, plus 3 is positive 6. 3 times 3 is 9, plus 3 gives me 12. So these are my new coordinates. Okay, and again, I did my x's and y's separately. Y's are exactly how it's written. X's are completely backwards. So two strategies that I showed was using putting it into factored form, which it already was, and doing shift last, or undoing the notation to get the description of exactly what happened. And undoing that algebra will give us the transformation in the order that it happened.